Welcome to Maths for You channel. Past question on trigonometry. Let t equal tan theta by 2 for theta not equal to n plus 1 pi, where n is an element of integer. Show that cos theta equal 1 plus t squared divided by 1 plus t squared. Reduce that tan pi by 12 equal to minus root 3. Let's start with the first part. The theta t is given as tan theta by 2, and we have to prove cos theta equal 1 minus t squared plus 1 plus t squared. What I prefer to prove, the right hand side to equal left hand side. In other words, I want to prove 1 minus t squared divided by 1 plus t squared is cos theta. Be easier, I think. Let's take right hand side. That is 1 minus t squared plus divided by 1 plus t squared. We know what t is. So 1 minus t squared is 1 minus tan squared theta by 2 divided by 1 plus tan theta by 2. And we need to cos theta, so we just bring it down to a sort of sine cos format. So 1 minus tan squared is sine squared theta by 2 over cos squared theta by 2. And the 1 plus tan squared theta is sec squared theta. The 1 plus tan squared theta, sec squared theta is basic trigonometry property. So the denominator, the LCM, is cos squared theta by 2 LCM. Therefore, cos squared theta by 2 minus sine squared theta by 2 divided by cos squared theta by 2. And sec squared theta, we can write it as 1 over cos theta sec theta. Therefore, sec squared theta 1 over cos squared theta. And the cos squared theta on the denominator and the denominator of nominator, and the cos squared theta, the denominator of denominator, will be cancelled out. So what we left with, cos squared theta by 2 minus sine squared theta by 2. Cos squared minus sine squared is cos 2. So cos squared a minus sine squared a equal cos 2a. So therefore, cos squared theta by 2 minus sine squared theta by 2, the cos double of that angle, which is theta by 2. So cos 2 times theta by 2, which is cos theta. That is equal left hand side. Therefore, this way to prove it. Otherwise, you have to take cos theta, then change into tan by 2 format to prove it. So just whichever way you want to do it, you could do it. So this is what I prefer to do it this way. So cos theta is left hand side. That's proved. So that's done. Second part is deduce that tan pi by 12 equal to minus. So what they're trying to say is, without using the calculator, we need to find the value or prove that 2 minus root 3. And again, it's a hidden message. Is use the first part. So the second part is tan pi by 12 equal 2 minus root 3, which we have to prove. But if you actually, we know that we deal with the first part, tan by theta by 2. So if we compare that pi by 12 to theta by 2, so theta by 2 is 12, that is it, 12 over 2, theta is pi by 6. But we know that in the form of theta by 2 and theta, cos theta equal 1 minus t squared plus 1 plus t squared, which is 1 minus tan squared theta by 2 and 1 plus tan squared theta by 2. So theta by 2 is pi by 12, which we said that, compare with the first part, and the theta is pi by 6. So cos theta, we can write it, cos theta equal 1 minus t squared over 1 plus t squared. Cos squared, cos theta equal cos theta, we just took it as pi by 6. So cos pi by 6 is root 3 by 2. This is a normal value the students should know. This is cos pi by 6, which is cos 30, is simply the students should know root 3 by 2. So cos pi by 6 is root 3 by 2. So cos theta is root 3 by 2, as root 3 by 2 left hand side. The right hand side, we have that the first part, 1 minus t squared, 1 plus t squared. If we could cross multiply and get the equation in t. So if we cross multiply that, root 3 times 1 plus t squared. Root 3 times 1 is root 3, root 3, and root 3 times t squared is root 3 t squared. I just wrote that first, root 3 t squared plus root 3 equal the right hand side. 1 times 2 is 2, minus 2 times t squared is minus 2t squared. If you could bring that t squared to one side, the left hand side, we have already root 3 t squared. If you bring that minus t squared, 2t squared to left hand side, that will be plus. So root 3 plus 2 t squared. And if you take the number to the other side, that's 2 minus root 3. A t squared equal is 2 minus root 3 over root 3 plus 2. That's what it is. It's just root 3 plus 2 is t squared equal 2 minus root 3. So t squared equal 2 minus root 3 over root 3 plus 2. Again, this is very normal practice. If you have a cert and the pattern or the format is a plus b or a minus b, then we need to multiply with its conjugate to remove that root sign. So the conjugate of root 3 plus 2 is root 3 minus 2 or 2 minus root 3, because we already have root 2 minus root 3, so might as well keep it that way. 2 minus root 3. 2 minus root 3. So we have at the denominator a 2 plus root 3 and 2 minus root 3, which is a minus b. So a squared minus b squared equal a plus b, a plus b, a minus b. So it's just, 2 minus a plus b is 2 plus root 3, a minus b is 2 minus root 3. That is equal squared of a squared, b squared. A is root 3, so square of root 3 is 3. B is not a, sorry, it would be 2, take a 2, it didn't be. So 2 is the a, my 2 squared is 4, and root 3 is b, square of root 3 is 3. So 4 minus 3 is 1. That's what I put. So the denominator, 2 minus 3 to the power of 2 divided by 1. And t, this is t squared. So t is obviously plus or minus 2 minus root 3. 2 minus root 3. But we know that t is tan pi by 12. It's a positive angle. Therefore, tan positive angle is positive. So it's the minus will be negative. Therefore, minus will not be the answer. So therefore, is minus. So t equal minus 2 minus root 3 is not the answer. So so the t is t to the 2 minus root 3. So tan pi by 12 is 2 minus root 3. That is what we have been asked to prove. We didn't use calculator at all. We used the first part to help us to find the answer. Thank you. Please subscribe to the channel and share the contents with fellow students. Thank you.